stages of their life cycles, and ingenious cocoons constructed by caterpillars, using anything from fabrics and twigs to porcupine spines. Many of these specimens are the very first of their types to be catalogued by the celebrated European natural historians of the 17th to 19th centuries. On the second floor of the museum's Lepidoptera archives, next to a study room with trays of dissected insect genitalia on the workbenches, are a series of cabinets in which I am particularly interested. They contain the moths historically employed in the production of silk. One specimen of the Chinese silk moth dates to 1758. It is the same one that was examined by Carl Linnaeus, the scientist who made famous the two-name system, by which all animals and plants are still classified today. This was the type specimen, the animal that helped him to determine the fundamental characteristics of every moth of its type. The type he would call Bombyx mori. It was an insect that had become small, pale, and flightless through the generations of selective breeding, that set it along a path to complete domestication, and made it synonymous with the production of farmed silk. The first of its two names Linnaeus chose from a Greek root, indicating that this was an animal that produced silk. The second told of the silkworm's favourite food source, the leaves of the morus tree, Linnaeus morus alba, otherwise known as the white mulberry. Both the insect and its food plant had started life in northeast China many millennia before, somewhere around the middle reaches of the Yellow River. The silk of this moth had fascinated me for many years. As a small child, I watched the threads it produced being woven into long, narrow fabrics on hand looms in the south of India, intricately interlaced with fine gold wire. I grew up around a mother and many aunts who wore only that fabric on special occasions. During religious festivals, I saw those women dress statues of their gods in silk. Later, out of curiosity, I bought Bombyx mori eggs so I could see for myself how they made those threads. My caterpillars hatched, tiny at first, dark in hue, writhing as a mass in a brown cardboard box I kept by my fireplace. I fed them from a tube of mulberry leaf paste, but whenever I was in a park, I'd look for a mulberry tree, hoping I could take them fresh leaves as treats. As they grew, I watched as they exuded fine, white, luminous silk that held them securely to the surface of their box. As they fattened, the dark little larvae developed a bluish-white translucency when they became plump and round. I liked holding them because they felt soft and rubbery, like partially dried glue. Each had 10 fat little back legs that I knew would be lost when it became a moth, and they wiggled when they rolled. The transformation toward which they were slowly moving would be astonishing. I read that 17th century anatomists studying insect metamorphosis had cut them open right at about this stage, stunning the scientific world by revealing preformed adult parts underneath. So I watched their translucent skin to see if I could spot wings. I imagined taking a scalpel, pressing down until it burst through the buttery softness, and peeling away their outsides. But I couldn't do it. Like fat puppies, they sweetly rolled over when I moved them, until one morning they stopped writhing, stopped eating, and climbed upward on the paper tubes I'd left them. There they started weaving what looked like a random mass of string in every direction. By night, this mess of stray pieces formed a scaffolding that held aloft perfectly oval pods. At first, these were like the thinnest of veils through which the caterpillars at work were visible, writhing and turning their heads in slow motion as they worked up successive layers into their precisely shaped cocoons. By morning they were ensconced, and I could no longer see through to locate them. And so I said a final goodbye.